Hi everyone, Mrs. Below here. In this video, I'm going to be going over more problems associated with limiting reactants. In the part 1 video, I went over how to find the limiting reactant by converting both reactants into the same product. But in those problems, I was starting with moles. In these problems here, I'm also going to start with moles, but then I'm going to take it one step further. So this problem here, first of all, the reaction, I have calcium hydroxide and hydrochloric acid, which will create calcium chloride in water. This is actually a acid-base reaction, which we will cover later in the semester. And the question is, what mass of water, and water is one of the products, would be formed if you had 6.3 moles of HCl and 2.8 moles of CaOH2, which is calcium hydroxide. So in this problem, I was just finding the limiting reactant, which we still have to do in this problem, but then we're going to do one more step in the picket fence to figure out how much product would that actually make. So since this question is specifically asking about water, which is one of the products, I'm going to then convert both reactants into that product. There are two products for me to pick from. I mean, I could pick this one, but it would just create more work for myself. So if the question does specify a specific product, then make sure you convert into that product. If this was just asking for the limiting reactant, then I could convert into either one of these. Because in this previous problem, we only had one product, so we only had one thing that we could convert into. This question, we have two products, but the question is specifying which one we're going to convert into. So I'm going to do the same thing I did before. I'm going to do two picket fences, one for each reactant I was given. So I have 6.3 moles of HCl and I have 2.8 moles of CaOH2, which is calcium hydroxide. And I'm going to convert both of those into water because that is the product that the question is asking about. So for the first picket fence, I know my units that have to go here is moles of HCl. And again, if you're ever starting a picket fence with moles, then you want to go straight into using the balanced equation. And according to the balanced equation, that's 2 moles of HCl. And then above that, if you put something in the bottom here that came from the equation, whatever goes above it should also come from the equation. And above that, I'm going to do the moles of water because that's the product that I'm trying to convert into. So 6.3 times 2 divided by 2 would still just give me 6.3 moles of water. So that much HCl would produce this much water, which is the product we're focusing on. Now we're going to do the same thing with the calcium hydroxide. So again, I know moles of CaOH2 have to go in the bottom here. And then I look at the equation and it is 1 mole according to the balanced equation here. And then I am going to, of course, also convert that into moles of water because we're converting both of these into the same product. So then I can compare them to see which is going to make less product and therefore be the limiting reactant. So I have 2.8 times 2 divided by 1. So that would give me 5.6 moles of water. Okay. I'm going to cross off my units as well. Okay. So looking at this, the first thing I'm going to do is identify the limiting reactant. So 5.6, this is less than 6.3. So that means that the calcium hydroxide, CaOH2, is the limiting reactant because that is making less product, that made less water. So therefore, theoretically, this is the most water that can be produced in this reaction if this was what I had for those two reactants. So the most I can produce theoretically would be 5.6 moles of water because the calcium hydroxide, the CaOH2, would be used up first. But then the question said, well then, how much, what mass of water can be formed? Well, theoretically, 5.6 moles is the most we can form in terms of like the amount of water because the calcium hydroxide is going to get used up first. So I'm just going to do another picket fence and I'm going to convert then the moles of water into grams of water by doing a simple moles to grams picket fence. So I'd have to find the molar mass of water, which is 1.008 times 2 plus 15.999. So 1.008 times 2 plus 15.999. So it's going to be 18.015 grams of water. And again, I put this here in the bottom, 1 mole of water, because that's equal to the molar mass. And so then all I'm doing is converting moles into grams. So then I would do 5.6 times 18.015. And I would get 100. We'll go 4 sig figs, so I'll just round this one. This 8 will round up to 9 grams of water. So theoretically, this is the most water that could be produced because this was the smallest amount that was made because the calcium hydroxide would be used up first. That's going to limit how much product we can make. And then I just took that value in moles and converted it into grams. Okay, so now let's take kind of this one step further and work on the next problem. So again, here and here, I was given moles to start with, and I converted moles of both reactants into moles of the product, either the only product I was given or the product the question was asking about. And in this problem, I just found the limiting reactant. In this problem, I found the limiting reactant, but then I also found how much product that would make in grams by converting the smaller amount of moles into grams. So we're going to do the same thing here, except for instead of starting with moles, I'm going to be starting with grams. So here I have this chemical reaction. Notice there's actually 3 products to pick from, but the question is saying what mass of CO2. So that's the product I'm going to convert both of my reactants into. And again, if the problem wasn't, if it was just asking about what's the limiting reactant, you can convert into any one of those 3 products as long as you were converting both limiting reactants into the same product to compare them. In this question, though, it's asking about a specific product. And then instead of given moles, I'm given grams. So I have 55 grams of BaCO3 and 26 grams of HNO3. So again, I'm going to do 2 picket fences. So 55 grams of BaCO3. And then I have 26 grams of HNO3. So I'm going to convert both of these into this product here. But since I'm starting with grams, I'm actually going to have to find molar mass first. Hold on, I need to get let me find I need a periodic table. So for the first one, I know that grams of BaCO3 has to go in the bottom here, and I have to calculate the molar mass of that. So I'm just going to show my work off to the side here. So Ba is 137.33. So 137.33 plus carbon, 12.011, plus we have oxygen, 15.999, and we're going to multiply that by 3. So let me just get a calculator to do that. So 15.999 times 3 plus 137.33 plus 12.011. Okay, so 197.338. So since I'm, again, starting with grams, I have to find molar mass because then I'm going to use this to convert into moles of BaCO3. So all I've done so far is convert grams into moles. And again, 1 mole goes up here because below that is molar mass. If you're ever calculating molar mass, that's always equal to 1 mole. Now that I have moles, now I can use the balanced equation. So there'd be a 1 here. So that'd be 1 mole of BaCO3 according to the balanced equation. And then I'm converting it into the product that I'm looking for, which is CO2. And we have 1 mole of CO2. So now I just have to do, because luckily they're all 1s, so 55 times 1 times 1 divided by the bottom, which is 197.338. So I'm going to go 4 sig figs, so 0.2787 moles of CO2. That's how many moles of CO2 this would make. And now I'm going to do the same thing with this problem. I'm going to find the grams of HNO3. That's equal to 1 mole of HNO3. And then, so that would be 63.012. And again, that was by finding the molar mass plus 3 times 15.999. And then I will do the same thing. I will use the balanced equation to convert moles of HNO3 into moles of CO2. So again, this is coming from the equation, and this is also coming from the equation. We're converting both into the same product. I'm going to cross off my units. So then I would have 26 times 1, which is 26, divided by what's in the bottom, which is that 63.012 times 2. So I would get 0.2063 moles of CO2. So in terms of which is making less, this one is less product. So that means that the HNO3 is the limiting reactant. And then if, just like this problem here, we're being asked for the amount of CO2. So now we just have to do another picket fence to convert moles of CO2 into grams of CO2. And the molar mass of CO2 is 44.009 grams. And again, that's 12.001 plus 15.999 times 2. And again, 1 mole on the bottom here because that's equal to molar mass, which is above it. And then I would just multiply 0.2063 times 44.009, 9.079 grams of CO2 would be my final answer.